Hi everyone. Today I'm going to present my project called TaskFlow. TaskFlow is a background task processing system built using Node.js, Express, Redis, and Docker. The main objective of this project is to process long-running tasks asynchronously instead of making user wait for the API response. So let's first understand the problem. In modern applications, not every request can be completed instantly. For example, generating PDF reports or else sending thousands of emails and processing upload files. These operations can take several seconds for even minutes or even minute. So if we execute these tasks directly instead an API, the user has to wait until the task or work finish. This leads to slow response and request timeouts and unnecessary loads on the servers. Instead of modern application process, these tasks these tasks are going to process in the background. That is exactly what the task flow demonstrate, and the solution is simple that instead of executing the task immediately, the API only accepts the request, stores it in the Redis queue and instantly returns a task ID. A separate worker service automatically listens to the queue and processes the task in the background and updates the task status and stores the final result. The client can later query the task's status using the task ID. And the architecture is like the client can post a task and the API service Redis accepts the task and uploads it into the Redis queue, and the worker service task process the tasks and sends the results to the Redis, and we can get the task from the get tasks by through the ID API. So the architecture consists of three main components. The first component is the API service, and the second component is Redis, which acts as the message broker. The third component is the worker service. One important design decision is that the API and the worker never communicate directly. The only communication done through Redis because of this loose coupling, either service can be restarted or scaled independently without affecting the other. And the project structure is simple. We're gonna have three folders, like two main folders, which is API service and the worker service. And there is a Docker Compose file and the README and architecture MD. The project is divided into two important services. The API service acts as the producer, and the worker service acts as the consumer. And the Docker Compose starts Redis, the API and the worker together. And the let's look at the API service. The API service is intentionally lightweight. It never performs the actual work. So client when a client submits a task, the API validates the request and generates a unique ID, stores the initial task status as pending, and pushing the task into the Redis queue and immediately returns a 202 accepted response. This makes the API very fast because it never waits for task execution. And get API And about the get API, the second endpoint allows client to check the current status of the task. Depending on the state, it returns pending, processing, completed or failed, along with the result or the error message. And Redis is the communication layer between both the services, as I said earlier. Since the project has a single worker service with internal concurrency lists, provides a simpler solution while satisfying all the project requirements. And while coming to the worker service continuously waits for the new task, and like instead of consistent instead of constantly checking Redis, it uses a BR pop, which is a blocking operation. This means the worker sleeps until a task becomes available and avoiding unnecessary CPU usage. And the worker service supports parallel execution, and I configure multiple worker loops using the worker's concurrency environmental variable. Each loop has its own Redis connection. When multiple tasks arrives at the same arrives, different workers process them simultaneously. For example, with a concurrency of three, then the three tasks can execute in parallel, and the life cycle of the task is like it starts from the pending and processing and complete, or else it goes through pending, process, and fail. Every submission takes through a life cycle. So initially, the task is marked as pending. Once a worker picks it up, the status change to processing. Then, if execution succeed, it becomes completed. Or otherwise, a retry logic is gonna be triggered. So the entire system runs inside Docker, and the Docker Compose starts Redis and API service, worker service using a single command. Let's see that. If it's new, then you need to use hyphen f and build. As I've already built it, it's a waste of time, right? First, I started all the three services using the Docker Compose. And next thing which we gonna do is like once every service is get started and healthy, then we can now we can move. As you can see, the API is listening on a port 3000. So the next thing which we're gonna do is that let's just quickly post a task. Like the task is like it contains a task type which is a report generation and the user ID from the person which the task is being posted. So let's just quickly hit it. As we notice that the response is returned immediately with the task ID instead of waiting for process. Let's quickly copy the task ID, and my bad, we need to change it. As you can see, the status of the task was completed, and the creation time and the updated time was being shown. So the worker service receives the task from the Redis and starts processing it in the background. We can see the worker has took this task and it has it has successfully done, so it was updated to completed. And I have even task ID, and we can check whether the task is in a pending state or processing or completed or failed. So in this, I also added automated testing. So the project contains both unit testing and integration tests. Unit test verifies retry logic, validation, and task status transition, and integration testing verifies the complete flow from task submission through. Redis to the worker service, and finally status retrieval. So to conclude, TaskFlow demonstration how modern backend systems handles logic long-running operations efficiently. Instead of blocking API requests, tasks are processed asynchronously using Redis as a messenger broker and dedicated worker service. Through this process project, I gained particularly so the thing which I gained is like practical experience with the asynchronous processing, distributed systems, and produce consumer architecture, worker polls and retry mechanism, and Docker and automated testing. These are the common design patterns used in scalable production systems, and implementing them helping me better understanding how real-world backend applications are built. And this is everything about my project TaskFlow. And thank you for watching.